My name is Scott, otherwise known as Web and Root. This is a talk about breaking the Oracle, building an offensive security toolkit for OCI, otherwise known as Oracle Cloud Infrastructure. This is the talk I gave at B-Side San Diego 2026, so I am just re-recording that talk with these slides and covering essentially the same info, albeit with maybe a bit more detail as time allows. So jumping right into it, a little bit more about myself. I'm a labs researcher at NetSPI. My handle is at Web and Root, which you can find me on social media platforms like LinkedIn. I have around 6-ish years experience in info security. Some of the things I've worked with in the past include things like web applications, GraphQL, Okta, 3 main cloud environments, those being GCP, AWS, and OCI, external networks. I've written some open source tools in the past, like adding support to Pacu for AWS organizations, or like I did a talk a year or two ago at Forward CloudSec and DEF CON Cloud Village on GC Pwn. Speaking of that, if you haven't checked out GC Pwn in a while, I would also encourage you to check that out if you're looking at GCP environments. Added a bunch of stuff to that tool, like pip installs, graphing, Bloodhound style graphing, and some other items. This talk isn't about GC Pwn or GCP, but again, if you want to check that out, you can find it on the NetSPI GitHub repo under NetSPI/GCPwn. So switching gears to OCI, right, or Oracle Cloud, one of the biggest things I always ask myself when watching a presentation or having to give a talk about the presentation is, like, why should we care, right? Like, why is this important? So the graph shown below pretty much aligns with what you'll see in most graphs, in that if you look at cloud providers who have most of the market share, almost every graph is going to tell you that it's Amazon AWS, Microsoft Azure, and Google GCP, right? Those are kind of the big three. Any graph you look at, those are going to have the highest market share. But because they have the highest market share, you might not hear about some of the other cloud platforms, because there are other cloud platforms out there, like IBM, Oracle, and some others, right? And so if you look at the graph there towards the bottom, you can see that Oracle does have some market share. And so while it's not, again, comparatively based off the graphs that you would probably pull today, while it's not among the top 3, it still does have some type of market share, and so there are still people who are using it, and so inevitably you are either going to end up using it yourself or are going to have to end up having to pen test it, right? Depending on your job role and what you're looking at in terms of use cases. And so besides the fact that Oracle Cloud does have some market share, and so then another thing is just looking at OCI over the past year. This was written at the time of making this presentation, and so if you look at over the past year and look at some of these news articles, you'll see they've made significant investments in places like Germany or the Netherlands. They made a really big push for AI, right? And regardless of how you feel about AI, right, that generates a lot of buzz and at least some adoption at the commercial level, right, or market share level. And so that kind of shows that more customers might join that kind of OCI suite of products. And then again, at the time of writing this, their latest earnings report was relatively positive. Over the past year, they've picked up customers like NATO Communications and Information Agency, U.S. Air Force, Greater Cincinnati Waterworks, right? So, obviously, like the U.S. Air Force is not a small customer, right? So there are significant customers that do exist within the OCI ecosystem. So regardless of the OCI market share, they do have some significant customers, and they have been making significant investments. And so again, it's that case of like you're probably going to end up using it at some point in the future, or at least pen testing it. I was focusing on it from a pen testing perspective, and so one of the things I wanted was a suite of tools to pen test an OCI environment. And as we'll cover here, once you actually get into those OCI environments and look at how everything is set up, it necessitates the need for certain tooling that just didn't exist as I was going through the kind of cloud environments and learning that, and so that's what this presentation is basically on. Before we get to the actual tools, though, I just want to do a quick Oracle Cloud 101, just in case you're not super familiar with Oracle Cloud and the different concepts behind it. At B-Side San Diego, I made a lot of comparisons to AWS and GCP because that's where I come from in terms of kind of cloud providers and cloud providers I know or pen test or have seen. So throughout this, I'll make a lot of comparisons to AWS or GCP. So if you're coming from those worlds, hopefully it'll make more sense with these comparisons. So the first thing, just before we get into anything, is I'll say OCID, or I'll mention the OCID. I bring this up because the OCID is a unique identifier. You'll see that abbreviation a lot. It basically is structured in such a way as shown below, where it's like OCID1, and then you have your resource type, your realm, your region, future use, unique ID. Again, the OCID is just regardless of whatever cloud environment you're in, if you have the OCID, it is a unique identifier to that resource. If you're coming from the AWS world, this is like an ARN, right? If you're coming from the GCP world, this is like that long string to define a resource, right? Like project/resource/ whatever that string is. So next thing we're going to talk about are tenants and compartments. So compartments are kind of the most atomic building block in terms of OCI structure and the way to organize things. If you're coming from AWS, compartments are like AWS accounts. If you're coming from GCP, compartments are like GCP projects, right? They're basically just purely logical nestable boundaries used to store group resources. So you might have one compute instance in compartment A and 3 compute instances in the root compartment, right? In all the compartments, you still can access all the different services like compute, cloud storage, or object storage, or whatever service you want to use. It's just where you're actually creating the resources and having the resources run is like you're just dropping them in different compartments, right? It's the same service. The resources are just stored in a different compartment. The tenant, you can think of this as just a, quote, special compartment. It's basically a compartment that exists at the root level. It's also called the root compartment in some of the documentation that you'll see. And so, again, it functions almost the same as a compartment. Like you can put compute instances in the root compartment if you want. I'm pretty sure you can put buckets in the root compartment if you want. For all intents and purposes, you can really think of it as just a compartment. It's just the OCID, that unique identifier, is slightly different in that it labels it as a tenant as opposed to a compartment. But again, as we'll see shortly, you can put whatever you want in that tenant usually. I'm sure there's caveats, but that's kind of what I've observed as I've gone through this. Other big thing is compartments can be created in other compartments, and IAM inheritance generally flows from the parent compartment to the child compartment. So if we look at the picture on the right, you'll see you have your root compartment, right? And then compartment A, and then compartment B is in compartment A, and then compartment C is in compartment B, which is in compartment A, right? So you can kind of nest all of these compartments. And then if you think about it from IAM perspective, if someone has permissions at like the root compartment, right, or compartment A, let's say, those permissions will propagate downwards. So if I, Scott, can access all the compute instances in like compartment A, then that will usually trickle down to I can access all the compute instances in compartment C, right? So if you can get access to the tenancy level, then by inheritance you most likely can compromise the entire environment, right? From a pen testing perspective, if you can get some form of like administrative access over the root or tenant compartment, right, depending on whatever you want to call it, then because permissions propagate downwards, that means you can pretty much control the entire environment. I'm sure there's caveats, services, and other things I just haven't had time to look into before this presentation that maybe can help restrict that. But in general, from like a general IAM sense, that's kind of what I observed when I was going through the environment. This is just a graph showing that like how complicated this can get, right? And this is where we get into IAM and why there's a need to enumerate these environments. Because you can have compartments inside of other compartments, you can kind of just keep nesting them, right? So we have our OCI tenancy compartment, and then we have application A compartment, and then within that we have 3 more compartments, right? And then we have application B and C, and so you can have virtual machines in all of those individual compartments, and you could put like virtual machines in the tenant compartment if you wanted, or you could put virtual machines in the application B compartment, right? So it's a lot of compartments and compartments being nested and then creating resources in those different compartments. And so if you're not organizing it well or have a high level view, it's very easy to, for example, put something in a compartment that you might not expect, right? Or maybe not easy is the right word, but it's harder to keep everything restricted to the intended compartments, right? Because there's so many compartments. And then again, this is a similar graph, right? So you have your tenancy, and then you can just see how many boxes there are as you start making compartments instead of compartments, and then nesting them, and then it just kind of it keeps growing. I think there actually is a limit of like how many compartments you can put inside a compartment. I want to say it's 4, but I know the OCI documentation states that. Okay, so that's all compartments. So like compartments, compartments, services, creating resources in those compartments. The next thing I want to touch on are identity domains. Again, this is kind of different than AWS and GCP. There isn't really a great direct comparison. This is a very OCI specific thing. But identity domains are logical groupings of IAM users, groups, dynamic users, and other identity information. They're usually given a simple name, and there's usually a quote default identity domain. In simple words, all this really means is when you create, so if you think about it in AWS or GCP, when you create users, right, there's usually that concept of users and groups, and you can put users in groups, and then you have you can do federated, you can set up federated authentication, and you can do a lot of stuff in IAM, right, in either AWS or GCP to create the principles you need or create the federation you need. In OCI, they take all the users, groups, credentials, federation, password policies, and they kind of bundle them all together in an identity domain. And so you can have multiple identity domains. I've really tried figuring out why this exists and have read a lot of the documentation, and basically from what I've gathered, to make identity domains, OCI merged an existing identity solution called IDCS with their OCI platform. And so because there's this weird merge happening, what you'll see at an SDK layer is that you'll see the users, groups, etc. in a self-contained application with its own authentication scheme. Again, backing up, what this means is, let's say you run a business and you've got a couple companies in your business, right? And you put company A in identity domain A, and you put company B in identity domain B. And so identity domain A is going to have all your users and groups and federation policies and password policies that correspond to company A, whereas identity domain B is going to have all your users and groups and federation policies and whatever that pertain to identity domain B. They both identity domains exist in OCI in a compartment, but it's it's almost like not to confuse anyone, it's almost like a mini compartment, right? It's almost like it's a logical separation of IAM resources. So you can separate them by another boundary per se, and that helps because you can have certain users in one identity domain that has a specific password policy versus others, and break it up that way. So the interesting thing there is when you're referencing a user in an identity domain, you usually want to prepend the identity domain name because, for example, in our previous example, maybe there is a user called Scott at company A, and there's a user called Scott at company B. In OCI, if you looked at both identity domains, you would see the Scott user. And even though both users are named Scott, they're completely separate IAM principles, right? And that's where the identity domain comes in. If you were to write out their full name, prepending it with the identity domain, even though they're both called Scott, the identifier would be different, right? So the idea is that just the idea or takeaway there is because you can have multiple identity domains, you can have users with the same name across multiple identity domains. They just have a different, unique identifier in the background. So that was a lot of talking about identity domains. This is what it kind of looks like from OCI. You can make your own free OCI account and see what this looks like. But you can kind of see at the top there, you've got my identity domain. So that's what my identity domain is, just called my identity domain. And then you can see within your identity domain, you can manage users. You can actually create your own administrators or roles within your identity domain to manage users. You can have dynamic groups, which we don't really cover in this talk, but dynamic groups are a way to group resources into a group as opposed to users. You can integrate applications, you can manage password policies, handle federation, and so that's the identifier, and usually there is a domain URL where you can get to it. Again, I don't cover it too much in this talk. I'll probably cover it in future talks, but this is really just to let you know that IAM entities in OCI are generally grouped into identity domains, and so we'll see that shortly in the policies. All right. And now, speaking of policies, so if you come from AWS, you have IAM policies, right, that say what someone is able to do. If you come from GCP, you have GCP bindings, right, that say what user is able to do what. In OCI, it's called policies, and you attach policies to compartments. And each policy has individual statements dictating permissions. There are several different statement types. In this case, we're going to be focusing on allow statements because those are probably the simplest and most used, I would imagine, statement types within policies, which you'll notice pretty quickly, and which is kind of weird again compared to AWS or GCP, is that policies are written as statements that are like lexical sentences. So you can see in the bottom left there, it'll say like allow group A to manage virtual network family in compartment A, right? It's kind of like a, I guess, I'm not like a linguistics major, but like, it's not like a simple JSON serialized format that you might see with GCP or AWS. It's just like a grouping of words in a structure. And so usually the policies are written in the case of like the user group or service is allowed to do some action on some resources in some compartment tenancy with conditionals, right? So like all the other cloud providers, you can add conditionals usually to policies if present. And so looking at our diagram here, this is what I was kind of talking about before, how permissions propagate downwards. So we create this policy on the left here, for example, and this policy is made of two statements, right? Two allow statements. And then we could bundle this policy and we could attach it to the Project X compartment. And then this policy would propagate downwards to Project X test and Project X prod, because inheritance in IAM goes downwards. Likewise, we could create another policy called, policy Y or whatever you want to call it. We could attach it to this compartment. The summary here is basically all the policies you make get attached to your compartments, and the compartments in turn have resources inside them. So policies breakdown, just diving a bit deeper into that, these are the allow statements. So you have allow some type of subject to do something on something in something, right? And so starting with the subject, usually when you're writing statements in OCI, you specify a group or dynamic group simple name or OCID. Something important to note is unlike AWS or GCP, where you can usually designate specific users, right? So you can say the user Scott has these permissions. In OCI, you generally, with some notable exceptions we'll note later, generally you have to specify a group or dynamic group. So if you want to give a user permissions, you have to put a user in a group, and then you have to specify that group name in a policy, right? There is no way to say like allow user Scott to do something. It has to be allow group ABC to do something, and then Scott needs to be in group ABC. Because identity domains exist, right, when you're specifying a group or dynamic group name, you usually need to prepend it with that identity domain name as well. Because again, if I say allow group ABC, well, I could have a group called ABC in identity domain 1, identity domain 2, identity domain 3. And so you usually just need to prepend it with whatever identity domain you're referring to. If you don't prepend it with anything, OCI usually defaults to like the default domain, or they usually have some type of default in place. Two noticeable keywords are any group and any user. If you specify any group, it includes all groups and dynamic groups. If you specify any user, it includes all users and resource principals or instance principals. If you're coming from the AWS or GCP world, any group and any user are like the equivalent of, not one for one, but they're very similar to like star or all authenticated users, right, or all users. So from a permissions perspective, those are kind of ones you want to look out for to make sure they're not erroneously applied. And so that's just who's able to do something. And then the permission stage is what can they actually do. In OCI, there are numerous individual permissions. For example, user update, that usually you need one or more of them to call a certain API. Because there's so many, OCI has basically bundled them all together into 4 basic verbs. If you're coming from GCP, this is very similar to like basic roles, right? And so in an order of least privileged to most privileged. That is inspect, read, use, manage. You'll usually see that all over in policy statements and documentations. And again, basically they've taken all these individual permissions in the background and bundled them together into these different verbs. So like inspect will have the permissions that just really allow you to list stuff, but then read will usually include all the permissions from inspect as well as permissions to actually read some metadata, and then it just keeps going onwards. Manage, right, is kind of like the equivalent of admin. So again, from a pen testing perspective, if you can compromise something that has manage, or you can control something that has manage, usually you can control whatever resources it's pointing to. You don't have to use these verbs. You can actually still specify those individual permissions if you want. But again, it seems like, I think based off the documentation, it seems like verbs are kind of the easiest way to set these up. Resource types, so we've said who can do something, what permissions do they have, and then what can they actually act on, right? If Scott has managed permissions, well, managed permissions on what? Is it managed permissions on the compartment, managed permissions on the buckets? And so from a resource type perspective, again, this is something that's maybe not as similar to AWS, where in AWS and GCP, like in AWS, you can specify a very specific ARN you want to target for a resource, and in GCP, you can sometimes apply bindings on the specific resource. In OCI, you have to use broad category terms like instances or buckets. So something like allow Scott to manage buckets, right? That means all buckets in whatever the location is. It's not like a specific bucket. And then they also have this concept of family. So if you want to go even broader in terms of resources, you can do something like instance-family. There's a bunch of these families that are predefined in their documentations. Again, a noticeable keyword is all resources. If you see all resources, that means everything. Again, from an AWS perspective, that is like the equivalent of star. So if it was like allow Scott to manage all resources, that basically means Scott has admin permissions over all the resources, like everything. And then you can see a table on the right there that just lists some of the example families and then individual resource types. Again, the big takeaway here is like I can't specify a specific resource ID in this sentence. I have to do a very general instances or buckets or a family. If you want to specify specific resources, you really just have to use conditionals, it seems like, to say like allow Scott to manage instances in this location where the instance ID is 123, right? Something like that. There's no way to just do it in the resource clause itself, from what I've seen. And then location, so like allow Scott to manage instances in where, right? Can he manage instances in compartment A? Can he manage instances in compartment B? The whole tenant, where these permissions scope to. So location is usually a compartment name or ID. A noticeable keyword, again, is in tenancy. If you ever see a statement that says in tenancy, that's just a shortcut to basically say the entire tenant. Now, that doesn't mean that if you see something like in tenancy on a child compartment, that means you just suddenly have permissions at the tenant level. It just basically means everything in the tenancy from your compartment scope down. So it's just kind of like a shortcut. One thing to note, so maybe going back here real quick, right, is when you specify location, you can do either your current compartment or child compartment, right? So the policy on Project X here, they could say like allow Scott to manage instances in Project X test, right? And then even though the policy is attached at Project X, because I've specified this child compartment, my permissions would only work in this child compartment. Or I could say allow Scott to manage instances in compartment Project X, in which case my permissions would work in Project X and both of these child compartments. Or I could say allow Scott to manage instances in tenancy. And then if it's in tenancy, you would start at the root, and then you would go down to where your current compartment is that the policy is attached to, and then again it would just be Project X and both child compartments. So that's kind of how the scoping works. And then conditionals is the last thing, where it's basically any or all clauses. There's a bunch of different conditionals. You can specify like ID targets, you can specify time constraints, you can specify a whole bunch of stuff. As we'll cover here shortly, the tool does handle some of this, but there are a lot of different combos you can do. And so now we'll just look at some quick example policies. So I've already mentioned a lot of these throughout this talk, but this just kind of gives you some examples of some of them, right? So you can specify multiple groups if you want, so like allow group A and B to manage all resources in compartment projects A and B. You can do the ID, so remember that OCID I referenced at the beginning. You can use an OCID to reference that group. You can do any group, right? You can do dynamic group. You see in that dynamic group example, there is an example of using an individual permission as opposed to just a generic verb like manage. And then that last one shows the identity domain prefix, right? So I have a group called group admins, but group admins might exist in many different identity domains. So when you're specifying the group in the policy, you prepend it with identity domain 1 /, right? So if you ever see that kind of syntax, that's all it's saying, is you're specifying what identity domain that group is in. So if there's a group admins in identity domain 2, that would not be captured by this policy, right? It's only the group admins group. It's only the group admins group in identity domain 1. And then you can see at the end we have some conditionals there, right? So that group can manage groups in the tenancy only if the target group starts with a dash and is not a dash admins. You can see at the top, though, that large workflow. Things can get very complicated very, very fast. This is just one statement type, right? So this graph here is just for allow statements with identity domains. But technically, you can have allow statements without identity domains, and then you can also have admit statements, endorse statements, define statements, and one other I'm probably, deny statements, right? And they all have their own workflows, and so just trying to handle all of this is a lot more difficult from my perspective, or at least in my opinion, from AWS or GCP, where it's like very serializable and you can just parse it all. Here, it's like a lot of kind of sentence structures that makes it hard to handle. And then I won't dwell on this too long, but this is just showing that inheritance, right? So if I attach a policy at the root level, right, then those permissions are going to propagate downwards. In this case, I added a conditional that said, hey, allow the group to manage instances in the tenancy, right, so the current compartment and everything under it, where the target compartment is not compartment C. And so you can see the permissions only apply to the root compartment, compartment A, and compartment B, but I use conditionals to exclude compartment C. So that's kind of where you can use conditionals. All right, as you're probably thinking, that was a lot of words, a lot of sentences, and it must be really frustrating to parse these because if you think about it, everything we saw was like sentences. So imagine if you're trying to write programmatic tools or work with an SDK. From what I can tell, OCI does not give you a way to serialize those sentences into like JSON or YAML files, right? Like when you go into the SDK and you list all the policy statements, you literally just get back the strings. Like there is no convert to JSON native way. And so if you think about all the different statement types and all the different rules and all the different structures and all the different ways you can structure each individual resource, it gets pretty tough to parse it. And so that's basically where I ended up, is I was trying to use the SDK tool to really analyze IAM policies at scale, and then as you dive into it, it gets really frustrating and kind of devolves into trying to parse blank spaces or syntax. Maybe this sentence uses the word to, while this sentence does not. And then you have to handle identity domains, but if there's not an identity domain, then you don't. And so it's just a lot of like regular expression parsing, and just basically devolves into a headache. And like I said, there isn't really an OCI native library they offer to convert these into JSON. So I created a lexical parser in Python that's both in GitHub and PyPy per the pictures below that converts incoming OCI IAM policy statements, again those being allow, endorse, admit, define, deny, into JSON output. It also, again, which we won't really cover in this talk, but it also covers dynamic group matching rules. Dynamic groups allow you to group resources into a group. The only way to put resources in that group is to use kind of conditional, like, again, just like phrases. There's no like JSON serializable format, and so it also converts those as well. You can find it again on GitHub and PyPy per the pictures below. And the way I basically did this is I used ANTLR under the hood. So if you're interested about it from a technical perspective, I just made different ANTLR files and used those to parse incoming sentences, turn them into tokens, and then return those tokens into a JSON serializable format. I should note that this was already handled by, and I think I have it on the last slide here. It was already handled by someone else at Oracle. They actually put out a blog post, I want to say 3 or 4 years ago, that talked about how you could use ANTLR to parse their IAM policy statements. But it didn't seem like there was really any follow-up on that in terms of like releasing an official tool for all users. And so I basically used that research and then just built both of the ANTLRs for both the statement types. So this is just a video that walks through me using the tool. Again, this takes in those sentence-like structures and basically spits out a JSON at scale, right? So you could feed it like 100 policies and it'll spit out 100 JSONs. It does like error reporting and some other stuff I'll touch on, but this is just an example of using it. So I have pip installed the tool here. I am on my local Kali machine. Or I am pip installing my tool here, so you can pip install it right. So I am pip install OCI Elixir parser. Great, it's been installed. I made this sample program as like a demonstration. So you can see I have two OCI statements at the beginning there, right? I've got allow group to group object writers to read buckets, and then allow group object writers to manage objects with some conditionals at the end, right? So kind of two typical statements. This is what the OCI SDK will return. So if you use the OCI Python library and list out the policies and return the policies, you'll see a bunch of sentences like this. And so basically I'm taking those strings just like you would in the OCI SDK. I'm passing them into my function called parse policy statements, which is in that library. All you have to pass in is the list of strings. I think it accepts both a list of strings or just one big string blob like this. And then it also has different error mode reporting options. So in this case I did report, but you can do things like stop parsing if you run into an error, continue parsing but return the errors, like there's a lot of different stuff, and then just return the payload and diagnostics at the end. So if I go ahead and run that file, yep, what you will see, right, is my two sentences have been converted into a JSON format. And so you've got the schema version, you have the statements, so it's an allow statement. It is a type group subjects. This is what the label is. These are what the actions are. It's a verb for read, right? You've got specific resources, so buckets. Basically just converts it all into a JSON. You've got, yep, actions, resources, you've got your location. And then, like I said, it does multiple statements. So then it handles the second statement, right? And it breaks that out into a JSON. And then at the end of the second statement, you can see it handles conditionals. So it parses the conditionals as well and puts those into easily parsable phrases, sections for you. So one thing to note, oh, and then it does diagnostics at the end, right? So in this case, I had no errors, but if there were errors, it would like print out what the errors were. If you think this is a lot of JSON keys and you need to like memorize it, don't worry. If you go to the OCI Elixir parser GitHub repository and go to the wiki page, again, going to github.com/netspy/OCI Elixir parser and clicking on that little wiki tab, I have all the different keys possible that will be in the JSON listed out in a table, so you can skim through that and see what best fits your use case and handle it again in your own workflow. So ideally, you could run your own tools, and this is what I'll do later in OCI Inferno. And how OCI Inferno works is you run all your tools, collect all the policies, pass them through this function, and now you have a list of JSONs to parse through, which is a whole lot easier than trying to parse through just kind of arbitrary syntax or sentences, right? And then I think the last thing I cover here is that was policy statements. Again, we won't really cover this in depth in this talk, but it also handles dynamic matching groups. So this is what like a typical dynamic matching group looks like. Again, it kind of just looks like one conditional, but again, it's very sentence-y, right? It's not like JSON. It's just a bunch of different conditionals. And so this is also hard to parse, right? And so I have another function in this library called parse dynamic group matching rule, and when I run this, you will see that a JSON again gets returned. And so, oops, moving on. So this tool has a lot of different things in it, right? So you have SDK and CLI integration. I showed SDK integration. It also supports the CLI. The focus just being that it can be used in whatever tool you are using. It does bulk processing of IAM statements, so you can throw in, 100 IAM statements in one go, and it will just parse them all for you. Has flexible error modes. Again, all of this is in the wiki, so go check out the wiki as well if you're interested. But it does different error handling modes, detailed diagnostics. It does filtering. I didn't show it here, but you could filter. So you could say like, hey, I want to parse all these IAM policy statements, but only return statements with this filter type. And then it also does simplified management of nested conditionals. So you saw you can have conditionals that are like and or operators, basically. And so if you want, the tool will also go through that big conditional tree and just simplify the Boolean logic for you. So if you have an and condition inside of another and condition, that's really just one big and condition, right? And it will kind of simplify for that for you and bubble it all to the top. Again, you can check that out on the wiki. But the TLDR here, right, is you can take all these simple sentences from IAM and efficiently serialize them into JSON format to then be used in other tools. Okay, and then the second tool I have is OCI Signer. This is going to allow you to sign OCI requests. So jumping right into it, some of the background. So if you come from the AWS world, you're probably familiar with SigV4. If I don't know what the equivalent is over in GCP, but when you go to make commands from the OCI CLI service, so if you download the OCI CLI tool and you start doing things like, I don't remember if these are the exact commands, but you do things, like OCI list buckets, right, or whatever those commands are. If you actually intercept that traffic, what you'll see is all the HTTP requests that get sent to the OCI server are being signed with a signature that usually involves some form of like a private key and then token with an overall RSA SHA-256 signature. Usually and we'll cover this in the talk, but there's kind of four main methods of authentication. Long-lasting API keys. If you're from AWS or GCP, these are like user access keys or GCP service account keys, right? They're API keys you make, and they tend to last kind of forever until you either delete them or remove them. Short-lived login session credentials. These are very similar to, if you're from AWS, these are kind of like temporary role credentials. If you're from GCP, these are kind of like temporary access tokens. And then compute instance authentication is kind of specific to OCI. In GCP or AWS, you have your IMDS endpoints, where if you're on a compute server, you can pull down the credentials for the service account or role attached to that instance. It's a similar concept, but in OCI, compute instances are placed in dynamic groups, and then to get the credentials for your compute instance to then call things as that compute instance, which is in turn in a dynamic group, they kind of have their own special, not special, but like specific form of authentication for compute instances specifically. And then all other resources in OCI that support that type of kind of IMDSE authentication just fall into a fourth bucket of just generic resource authentication. So compute instances is just noticeable in that it's kind of a separate process as compared to a lot of the other resources. Like I said, if you're familiar with AWS, this is like SigV4. The signature is computed by taking a bunch of different pieces of the HTTP request and signing them. So if you, for example, were to capture one of those requests and send that request, and you change some part of that request without changing the signature, you would get an error on the server because you haven't re-signed the request. Another good example I should mention is this is kind of like Postman, right? If you've ever used Postman to send AWS requests using SigV4, usually in Postman you have to like add your access keys and add some other info, and then it will just kind of sign the request in the background and send it to the server. That's kind of what this is, again, like, right? It's like all these different forms of authentication. When they go to send their request, HTTP request to the server, they're signed, and there's kind of slightly different ways for how you get the creds to sign them depending on how you're authenticating, but in all the cases it's an RSA SHA-256 and usually some private key in some form of a token, again, in general. So when I was proxying the traffic for my later tool, which I'll cover, and you're intercepting all these HTTP requests, and you kind of want to try things out of, what if I change this parameter? What if I change this variable, or whatever you want to try out? It gets annoying because when you want to test it, every time you change something, you will receive an error from the server, right? Because you haven't re-signed the request. So if I do OCI list buckets, and then I capture that HTTP request, and I say, you know what, I want to try changing one of the parameters to something else, and I change the parameter and I forward that request, or I just, again, from Postman, if I send it, or I guess not from Postman, but if you send the request and it's not signed properly, then you're just going to get an error response from the server saying, hey, your signature does not match what I'm expecting. So I created a Java Burp Suite extension available on GitHub. You can find it under the releases page, the jar, if you want to add that to your Burp Suite, but you can basically use it in Burp Suite. It is very similar to AWS Signer, if you're familiar with that. It basically allows you to quickly and easily modify HTTP requests and resend them signed, and also allows you to emulate instance authentication, which I think is very interesting with respect to OCI. But again, the TLDR here is now, using this Burp Suite extension, you can have this extension loaded in the background with your credentials loaded into it, and then you can modify the HTTP request however you would want, and it will just automatically sign the request before it sends it to the server, regardless of your modifications. And so then you don't have to worry about always having to re-sign it and resend it and change the SDK and all that. It might make more sense once we jump into an example, but this is what it looks like from the UI perspective. So you can see on the left you get your different profiles. You have the different types of credentials you can pass in. So you can pass in API keys, session keys, instance principal, resource principal, config profile. When you're setting up the OCI CLI, it stores your credentials and kind of like metadata in a config file. If you're from AWS, again, this is very similar to .aws credentials file. If you're from GCP, I forget where that's stored exactly, but usually, on your local file system, .gcloud or whatever it is, there is files with your local access tokens and metadata about you. So the tool lets you just point to that config profile and just auto load in all your config profiles if you don't want to put in the data manually. So we'll jump right into it. So starting this. So this is my config file. So this is what I mentioned in OCI CLI. I set up my OCI CLI in the background, and when I did that, it created this config file for me. So my profile is called default. It's got my user OCID, the fingerprint of my key that I'm using, my tenancy OCID, my region, and the file path to where my private key is. Because again, a lot of these signatures in OCI, you need a private key. And so my private key is at temp OCI creds private key. Don't worry, this key has been deleted, as well as these creds. But you can see if you cat the OCI key, if you cat the PEM key, that PEM key showed up. And now I've opened up Burp Suite, and I'm just loading in my jar file from, again, that releases pages. So I got the JD key 21 here, so I just go ahead and load it into Burp Suite. Gave it a few seconds, and it has loaded in. So if I go to the OCI Signer tab, you'll see I've got my profiles. I've got, I can turn on signing. I choose what profile I want to sign with. I can specify the region. I've got all these different auth types in here. So if we did our config profile, right, I could point it to OCI config and just say load in my default config profile, and it will do that for me. Probably the easiest for most people. In this case, I'm going to walk through the API key example just so you know, or understand what it's doing. So if I go to API key specifically, and I start filling in everything, I'm just plugging in everything from that config file. So I'm plugging in my OCID for my user, I'm plugging in my fingerprint, I'm plugging in the file path to where my private key is. Private key or key passphrase is probably not really needed. I think it's just there in case you need it, but I don't really know of a use case when you'll need it, but it's there if you need it. And then tenancy OCID right at the top, and so we kind of have all our data here. And so the next section is going to be putting in a region, so US Phoenix 1. Make sure everything is set up, and then you want to hit save. Once save is clicked, you go ahead and hit test credentials. So something about test credentials, there is an API endpoint in OCI that requires zero authorization. right? It requires 0 authorization. All you need is authentication. This is this is not like a 0-day I'm dropping. This is publicly documented. OCI even says in their documentation this is a good API to use to test credentials. If you're interested in this endpoint, or I should mention at this point, if you're interested in any of these different authentication methods, I also have a wiki page for this extension that goes pretty in-depth into the different authentication methods, walks through examples of how to basically get creds for each of the authentication methods, and also mentions that namespace API endpoint. And that's what it's called, the namespaces API endpoint that requires 0 authorization and only requires authentication. And so when you hit test credentials for most of these authentication types, that's what it's calling in the background, as we'll see here shortly. So if I go to my logger tab, you will see it made this call in the background to object storage, the namespace endpoint. You'll see here's the signature, right? So you've got authorization signature, your key ID, your signature, all the different stuff that it computed in the background and added, and then it returns the namespace. So this proves like, yes, my credentials are valid. It doesn't say anything about the authorization, what permissions they have, right? Because again, anyone can call the namespace endpoint as long as you're authenticated, but it's a good POC to prove that like, yes, my credentials are loaded in correctly and my signature is being signed correctly. So now we actually want to try signing something. So I have a API here loaded into my repeater tab. You could also just easily do this in Postman, right? And this is going to list all the instances in that compartment I have there. Now, when I send this request, you'll see it fails, right? Because I have no signature. My signature is literally no signature supplied. So I sent this to the server. The server was like, you have no signature, you're not authenticated. So we're going to turn on our OCI Signer extension. So I'm going to enable signing. I'm going to go ahead and choose the profile that we loaded all our creds in, and I'm going to send the request again. And you'll notice, now that I sent the request again, it works, and I get all these instances back. You'll notice the signature has not changed in the repeater tab, because you hit send, this request from the repeater tab starts to get sent out, and that's when the extension signs it. So if you want to actually see the full HTTP request with the signature that got this response, you have to go to the logger tab. So yep, just showing it's still no signature there. If you go to the logger tab, yep, and so here's the request, right? So the logger tab will show the actual HTTP request that got sent out to the server, the kind of post-signed HTTP request. And so you can see our no authorization signature is no longer there. It got replaced with this big signature, the version, all that stuff, which is why we were able to list all the instances. Yep, so listed there. Alright, there's a bunch of other stuff in the tool. So that was standard SDK method. I have a manual signing method. I don't know when you would ever really need to use this, but if you want to specify different headers to sign, you want to remove certain headers, you want to use different algorithms, you want to like deviate from the standard, there's kind of like a manual, more complex custom signing you can do. Again, 99% of the time this probably isn't going to be applicable. Maybe if you need to like add a header or remove a header, but I just added it there. Yeah, so you have all the, you can do like HMAC if you want, right? And I didn't really test these super thoroughly because again, there's not really a big use case for these, but those are supported. Other big thing I have is signature calculators. So if you want to calculate the signature before you send the HTTP request, or you don't actually want to send the HTTP request, you can copy paste your HTTP request into here. Go ahead and hit calculator, or hit calculate, and it will give you the signature back and explain to you, it was there a second ago, but if you read through the debug, it'll explain to you, this is how I calculated the signature, to kind of help you walk through, okay, this is how I calculated it. And then another functionality is import. So you can also point it to a specific configuration file. So in this case, I'll do auto, which automatically goes to .oci config, and it will just automatically pick up all your profiles in there. And so if you have like a config profile with a ton of different authentication in it, and you just want to import them all at once, you can do that through this tool. So the other thing I'll mention is instance authentication. So instance authentication is a bit different. Basically, and I won't dive into it here, but the way instance authentication happens is usually the instance will exchange a series of certificates which will then vend back a token, I believe, which we'll see here shortly, and then that token is used in future HTTP requests to sign things. Again, check out the wiki. The wiki does kind of like a deep dive into all the different components. Again, that's going to be at netspy.com, or sorry, that's going to be at github.com/netspy/OCI signer. So this is just an example. So I set up a compute instance in OCI. I'm going to go ahead and SSH into it. This is like a compute instance in OCI, and then we're going to just hit the IMDS endpoints, which, again, if you're from AWS or GCP, you're probably familiar with this. You have to add this authorization bearer Oracle header for IMDS version 2, but you can see once I start hitting this IMDS endpoint, I can pull back the tenant ID, I can pull back region info about where this instance is, and then kind of the big things we're going to want are the certificates, the things that when we actually go to authenticate as that compute instance, the certificates that are used in the background. So first I'm going to grab cert.pem, and then I think I also grab key.pem, and then I grab intermediate.pem as the third. Yeah, so one thing to note about this is you saw I grabbed all those certificates from the OCI instance. If you try to look into the OCI Python SDK for authenticating as a compute instance, the documentation really wants you to run it from compute instances. There's not a great way to authenticate as a compute instance outside of a compute instance, right? Like most of the documentation you'll read will say, if you want to authenticate as a compute instance and do stuff, you need to run code from the compute instance, and here's the code snippet. Well, if you set up a bunch of reverse proxies and actually look at, okay, what is the traffic actually doing when I'm authenticating, you can see it's basically just doing an exchange of certificates for a token. And so you don't have to be on the compute instance to do that. You can do that off the compute instance. And so that's what this is showing. So I was just on the compute instance, and I catted all those key and intermediate and cert files. I then copied those to my local disk, so I'm no longer on the compute instance. I'm now just on my local computer. So I've got all this different stuff, cert.pem, intermediate.pem, and key.pem. And right, you can see I can cat. So again, I just copied this to my local file system. Back in our instance principal, we're going to start loading in all these different things. So I load in my cert.pem, my leaf.pem, or my key.pem. Again, probably don't need a passphrase, cert.pem. Then your federation endpoint. This is going to be a hard-coded value from what I've seen. It's usually going to be auth.region.oraclecloud.com. It's actually slightly different for the gov account, it seems like. Again, read the GitHub wiki. It dives into this specifically, but I believe the gov one is like just a slightly different domain name. So I think this would also work in a gov environment. Again, I just tested this in commercial, where it's going to be auth.region.oraclecloud.com. So you just got to type that in there. Now what's going to happen is it's going to send these, again, this is all from your local file system now, right? We're done with the instance. Ideally, you'd want to run the SDK from the instance, but we're going to do it from our local file system, or local host. So I put in my federation endpoint, and this proxy federation request, basically what's going to happen is when we hit test credentials, while all the other auth types will call get namespace, instance profile is unique in that when you click, I believe it's when you click test credentials or say, no, it's just when you click test credentials or refresh token, that was it, it will take those certificates you passed in and pass them to that federation endpoint. And that federation endpoint will give you back an access token, which is what we'll use, or I don't know if it's an access token, but give you back a token, which we will use for future requests. Now, if you want to see that exchange of providing certificates and getting back that token, that's what the proxy federation request check is for. And then you just got to disable TLS, or else it throws a TLS error, which is what that other box is for. But that's basically, although I'll have to check, but I think disable TLS verify, you do need to check it, or it might still work unchecked. But the short summary is, like, you definitely need the proxy federation request if you want to see that initial certificate exchange for a token. Otherwise, it'll still happen, you just won't see it in your logger tab. So in this case, I want to see it, so I'm going to go ahead and just check it. And then you can put in your tenancy OCID, although that's optional. It will pull it from the certs if possible. So I put in my tenancy OCID. I'm going to go ahead and click Save at the bottom. Then I'm going to hit Test Credentials. And what you'll see there is I hit Test Credentials. There was a pause. What happened in the background, which we'll see shortly, is it hit that Federation endpoint with these certs. That then returned a token, which then got cached, shown down here. And now when we go to sign future HTTP requests, it will use this token to sign them. And so we can effectively call any API as a compute instance without needing to call it from the compute instance itself. Because we just sign all our HTTP requests with this profile, and we are basically effectively signing everything as that instance profile. You can see it has like token expiry and created times down there. And this is what it looks like, that initial exchange. So again, because I have that proxy, you can see what it looks like. So I posted, I sent all these different certificates, and it just responded with one big token blob, right? And that token blob is what I'll use in future requests. So this was to get the token back. And again, normally this is something that would be invoked from the compute instance, or you would see this from the compute instance, but it's just an HTTP request, so we can just call it from our local host. Alright, so now we have our token. You can reveal it if you need to copy-paste the token for whatever. You have your expiry. You can refresh the token if it's before the expiry time. So we're going to call the namespace API and sign it as our compute instance. Remember, to call this API, you don't need any authorization. You just need to be authenticated. So to validate that, like, yes, we correctly have a token for that compute instance and can sign things as that compute instance, I'm going to call the get namespace API. What we'll see here is it says, nope, you're not authenticated without any signature. I'm going to go ahead and turn on my signing profile. Hit send, and a second later, there it is. And so if we go to our logger tab and we check what was actually sent, you'll see that no signature was replaced with this. So you can see, like, again, the signatures are similar across all the authentication methods. It's just they're slightly different in how they're packaged. So like with compute instance, you'll see the key ID starts with $, and then this is our token, right, that we got back, and then it computes a signature. And so that's kind of it. That just shows how you can call APIs as compute instances, which I think is pretty cool. And again, there's other auth methods, so go check out the wiki. So all the features, right? You can resend HTTP requests. 4 main types of auth. Scoping flexibility, you can have it only sign things that are in scope. You can change algorithms if you want, a little calculator preview. So this isn't too specific, but what we'll see is in OCI Inferno, or if there's any other tools where you can proxy OCI traffic, you can use this in conjunction with that to proxy all your traffic and sign it as something else, right? Because you could set a signing profile, and then that will just sign anything that comes through the proxy. Okay, the last tool we're going to cover here is OCI Inferno. So we covered a lot in terms of OCI, and so what would be super helpful is if there was a way to just enumerate all the OCI data and also graph it, because at the time I was working on GCPwn IAM permissions, and I was trying to figure out what is the best way to represent this complex web of IAM permissions. And so I kind of started with OCI as a POC to see could I graph OCI in kind of a Bloodhound style way. Luckily, about I think a year or two ago, Spectre Ops, jump to the next slide here, Spectre Ops released OpenGraph, which is kind of an open source model that allows you to graph any technology like Bloodhound. So I figured, well, let me try it out on OCI, because I'm sure that's a lot simpler than GCP, famous famous last words, as with many of the projects I tackle or start, but I figured that would be a good POC, and I'd also just get to learn OCI in the process, right? And a colleague of mine was also making an OpenGraph model for Salesforce, which that's actually in the picture below. Again, a quick aside, if you are interested in Salesforce or graphing Salesforce like Bloodhound, I would check out Forcehound, again, at github.com/netspi/forcehound. But for OCI, I was like, this seems like a good technology to graph those permissions, right? So I can parse all these complex compartments and policies and statements and locations and inheritance and just in one nice graph to see where everything is. So OCI Inferno is very similar to GCPwn if you're familiar with that. It is a Python-based tool for pen testers that enumerates OCI environments and provides an OpenGraph representation of privilege escalation paths. It's available in both GitHub and PyPy, right? So you can git clone it or pip install it. The last slide in this presentation has the reference slides, but you can also see it in the picture there on the right. The OpenGraph model is designed to handle both inheritance, and it also handles a subset of conditionals as well, so it will also handle conditionals. Other things of note, very similar to GC-Pwn, but it has one module to enumerate everything all at once. It has functionality to download data to disk, for example, bucket content or secrets from Secrets Manager, again, if you have those permissions. It has the ability to export all enumerated data to a CSV, JSON, or Excel file. You can set up proxying, rate limiting, other config options. On proxying, like what I mentioned before, you could set up proxying, proxy it through Burp, and then use OCI Signer to sign everything. Right, if you want to just run the modules as different things. And then it has an OpenGraph model, right? That is kind of like dependent on, it has different flags you can set depending on what you want to see. So jumping right into it, OCI Inferno, like I mentioned, is a GitHub package or pip. So I'm going to go ahead and do it through pip install. So what I'm showing here is I have set up my OCI CLI. So I created a user, I set up API keys for them, and I got it all set up on my local file system. But to actually enumerate everything in the OCI environment, I would have to make like a bash script, or I'd have to make like 100 OCI commands, right, or CLI calls. And so it'd be cool if I could load these credentials into a Python tool and just let it run, right, and enumerate everything and graph everything for me. And that's what we're going to see here shortly. So I got my creds all set up on local. And then I believe, yeah, I'm going to go ahead and just set up a test environment, virtual test environment, and I am going to pip install OC Inferno. So that is installed. I'm going to run the tool. It's very similar to GC-Pwn if you've seen that, but it asked, what do you want your workspace to be? Workspace just being a logical collection you can set up in the tool. I'm going to do test workspace, and then you can load in all these different types of authentication methods. So it's very similar to OCI Signer. You could do a profile, so you could point it to a config file and say just load in that profile. You could pass in an API key specifically. You could pass in a session token specifically. You could pass in an instance profile with those certificates that we were just looking at. You can pass in a resource principal, which is like basically all other resources beside compute instances if they support that. Again, the OCI Signer wiki, as well as the OC Inferno wiki, has more details on this. As I'm going through this, I should mention, again, OCI Inferno has a wiki. You can go to github.com/NetSPI/OC Inferno, and you will see under the wiki tab a detailed breakdown of a lot of this, and so you can read up on this later. But in this case, I'm going to go ahead and load my API keys because that's what I've set up. I believe in this case, I'm going to do the profile method because that's just easier. Let's see. Yep, I'm going to do profile. So profile, right, and then this is just what I want to, the label I want to put on my credentials. I just point the file path to where my config file is, and I tell it what profile I want. It goes, it checks the keys, it looks at what the file path is for the private key, it grabs the private key, it loads everything, and gets everything set up. And so now my keys are loaded into the tool. Now, it saves everything in local SQLite databases, right? So if I quit out of the tool, like I show here, and then I open the tool again, my workspace is still saved, and my credentials are still saved. And I can just resume with my credentials where I picked off. Of course, if your credentials expire after a certain time, this might not work as well, but for like API keys, right? In this case, this API key isn't going to expire, so I can just resume my session. So you can type in creds me, and it will tell you, okay, here's who you are, here's all your details. You can do cred swap. So in this case, I only have one credential, but if you have multiple credentials in here and you want to swap between credentials, you can swap between credentials as shown here. Modules, this lists all the different modules. Right now it's all enumeration modules, including enum all, right, and enum config check. And OpenGraph, which we'll see shortly. So the enum all is going to enumerate everything. Enum config is going to do some config checks based off the data in the SQLite database. And enum Oracle Cloud Hound data is the module that actually creates the OpenGraph model and JSON output. So we could run enum all, but I think in this case I am going to show just running one specifically. So I'm going to run modules run. There's also tab autocomplete on this, by the way. So modules run enum resource manager. If I run that, that's going to try to find all the compartments it can find. It prints it out in a nice, like, pretty table. In the future, I'll probably change this so instead of always being a pretty table, you have the option, which I've already done for GCPwn, but you can do text or table format, and you can choose to pip install the table format if you want. So that'll probably change in the future, but for now, this just is using the table. And so you can see it found a resource manager, so it found like some, or sorry, so this doesn't find compartments, this just finds things in resource manager, yeah, which is slightly different. I'm getting mixed up with GCP, but in resource manager, they're called like ORM templates and some other stuff. So it does some enumeration for the resource manager service in OCI. But if we don't want to like run all these individual ones, you can just run enum all, which I'll show here. And if you add the --comp compartment flag, right, the --comp compartment flag is going to try listing and enumerating all the compartments up front. So if you run enum all with --compartment, it is going to first try listing all the compartments, and then it will also try to run all the enumeration modules on all the compartments that are discovered. So if you want like the most comprehensive kind of enumeration of everything, you'll want the --compartment flag, and then --download says if this module supports downloading data, download it to disk. So I'm going to go ahead and run that here. And you'll see it found all these different compartments right away, and then it's still running below there, but now it's going through all the different compartments, and it's just trying to grab everything and just fast forwarding to the end. So after it runs here, you can see here's the results for everything, like this is how many resources I found in this compartment, and etc. Now that we've run that, you can type in compartments, and it'll give you a nice little tree output of all the compartments and what they look like. You can also set different compartments, so like at the moment, we are running things under the context of the tenant compartment. But if you want to run things under the context of other compartments, like if I wanted to run things under the preprog compartment, I could switch to different compartments, right? It's kind of like switching to different AWS accounts or different GCP projects. It's just where do you want to run the modules under. There is data export, so I can export all the data I just enumerated to Excel. So kind of the playbook is if you run enum all, you'll enumerate everything, and then you can run data export Excel to put it in Excel format. And it is going to, in terms of like what we got from enumerating, if you OCI Inferno output, you will see in that folder we have our report. We also have some secrets that were downloaded, so things that it downloaded to local disk were some resource manager stuff, some secrets secrets from the vaults, some bucket content. So again, that --download flags downloaded a lot of stuff to disk here, some API gateway YAML files. And then, yep, and then I think I just showed the Excel here. And so this is just showing, yep, these are the secret contents, right? Like I cat the secrets, and those are the secret contents that are returned. And then this is just like the Excel, right? So I just touched on it, but like data export Excel, you have a nice Excel document that you can filter on and see everything. So again, if you're like pen testing, you just really want to get a lay of the land of like what can I see, what can I get to, you can pull it up in Excel, right, and see everything. Okay, so that's mainly the enumeration, the data export, data download, all of that. So let's talk about the graphing part, right? Because that's kind of the big part. So now that we've enumerated all the data, now we can actually try graphing it. So at a high level, the things that are graphed are user group memberships, resource dynamic group memberships, identity domain IDCS application level roles, which again I won't cover in this talk, but identity domains allow you to set up application level roles within the identity domains, and so those have their own permissions, and so that also contributes to the graph. Currently it just handles allow IAM policy statements, and it also does resource expansion for like family resources or specific resource categories. It supports all those different edges. I will say in its default state, the OpenGraph module will only graph things that are related to privilege escalation. So like if you have read access over a bucket, it's not going to graph that, because by default, we only care about privilege escalations or like lateral movement or things like that. As we'll see here shortly, though, there is a flag if you want to turn on that and see everything, and you do want to see read access over buckets or anything like that. But by default, it just focuses on kind of like group membership type stuff and privilege escalation. So jumping into an example here, assume that we have a policy attached at the prod compartment in our tenancy. We have one policy called add self to group that says allow the prod group to update users in compartment prod. We have a policy called user organizer policy that allows privilege group to manage users in compartment prod. And we have an admin policy called allow group prod admin group to manage all resources in compartment. So we'll be showing the graph, or we will show in the graph that as a user in the prod group, you can add yourself to the privilege group, which in turn will allow you to create an API key for a user in the admin group who in turn have access to all resources. From a pen testing perspective, we're going to look at this like we are the prod user here, right, in the top left. So this prod user, they have the ability to add themselves to any group in compartment prod, right? So that's that edge. And then the privileged group is within that category, right? So you can add yourself to any group. The privileged group is part of a group, so starting from here to there to there. And then this privileged group has a policy called user organizer policy. They are the subject of that user organizer policy, and they can manage all users in prod. So then we follow this manage edge, because manage, remember, is kind of like admin. So if you're admin of all users, you can do whatever you want to become that user. So we jump over to users, and that includes our admin super secure user, and they are in the admin group, and the admin group is the subject of the admin policy statement, and the admin policy statement can manage all resources, right, which is the equivalent of like admin over star, which is not what you want, right? That's like administrator access basically at that compartment level. So kind of to summarize, we start here at prod user, we jump to groups, we then jump to privilege group, we then jump to this policy, we then jump to users, we then jump to the specific user, that specific user is in a group, that group is part of this policy, that policy gets you access to all resources. So to actually do this in the tool, we have run enum all. So you're going to set up Bloodhound, just the Bloodhound Community Edition, which I have set up here. You're going to need to copy one of the bearer tokens. So normally if you run the tool the first time, then you need to include that bearer token if you want the fancy pictures and colors. Otherwise, it'll just all show up as question marks in those little nodes. You only have to do this the first time. You don't have to do it for any subsequent times. But that's why I grabbed the bearer token to feed in here. Otherwise, for all future runs, you don't need to include that. You can just run it basically like this. So we're going to run enum Oracle Cloud Hound. Cloud Hound data. I'm going to add apply custom nodes attributes. I'm going to pass in my bearer token. Again, this is pushing the pictures and colors and kind of like formatting for my nodes. And then I'm going to specify an output file, right? I think it'll save it to a default place, but let's just make it simple and do OpenGraph import.json. Alright, so you can see, yep, it pushed my custom nodes stuff to Bloodhound, so when I import my data, I'll get the nice fancy pictures and colors. And then I'm just going to go ahead and upload that file I just made. So I upload that. Give it like a minute or two for the data to propagate. I'm fast forwarding a bit, right? And then I just wrote a cipher query to pull all the nodes and edges, and then I zoomed into our specific case. So exactly what I was talking about, right? We have our prod user. That prod user can add themselves to a group. All groups. The privileged group is one of the groups covered by just the generic groups resource. That privileged group is the subject in a statement, which means they are the subject in that statement, and the nodes and edges have like properties that show you all the statements and stuff. So it's saying that our privileged group is the subject of that statement, and that statement says that you can manage all users in prod. Our admin user super secure is a user. They are in the admin group. That group is also the subject of a admin policy statement who can manage all resources. So that's kind of the final privilege escalation, or not privilege, like lateral movement to get to all resources. So there's a lot of flags you can add on top of the graphing module. The picture on the left is a great sample of what kind of the most atomic unit of what most of these graphs are. Is you have a user who's a member of a group. That group is the subject of a policy, and that policy can do something on some resource. In this case, manage secret bundles. So that's usually what you'll see. Just as got like a quick aside for most of these relationships. In terms of this specific example, let's say we have a policy that's like allow group, tenant group to manage secret family in tenancy. Just in default mode, you would see the picture on the left, right? This user is part of this group who can manage all secret bundles, which includes these specific secrets. The problem is this was attached at the tenant level, right? So this is actually missing a lot of permissions because in tenancy means, again, your current compartment and like all child compartments in that tenant. So if this is attached at the tenant level, we don't just have managed permissions over secret bundles at the tenant level. We actually have managed permissions over secret bundles at the tenant level and at all the child compartments. So if you, I believe the flag is called -- expand inherited, but if you rerun the module that we saw in the previous video and add that flag and graph it again, you'll see now we have a more accurate picture of our permissions through inheritance. So we not only have managed permissions over the secret bundle at the tenant layer, we also have managed permissions over the secret bundles at pre-prod and prod and this compartment. And so it just fans out all the different edges to all the child compartments, and so it's useful when you're looking at inherited stuff. So it handles inheritance basically is the summary. And then conditionals. So for example, let's say we have a policy that is allow any user to manage users in compartment prod where request.userid is this big OCID. So if we graph it in the default stage again, right, you will see any user is the subject of this policy. That policy allows you to manage users at prod, right? So I don't know if I mentioned it before, but all these different resource nodes in the graph will be like resource at the compartment. So in this case, it's users at the prod compartment. So it allows you to manage users at the compartment, at the prod compartment, and then that includes like the prod admin user, as well as the prod user, right? So but if we look at the policy statement, that's not actually correct, right? Because this conditional here says, well, actually, it's only if the user it's only if the caller is this OCID, right? So it's not that any user can manage users in compartment prod. It's only when the calling user has this specific OCID user. So it's not any user, it's this specific OCID user that can do the action. So in our default state, it graphs like this, but I do handle a subset of conditionals. And so if you were to churn it, I believe it's called, again, you'll have to check the help menu in the module, but I believe it's called like conditional evaluation or -- conditional evaluation or whatever you want to add there. Again, it's all in the wiki as well on the GitHub, but if we graph the same thing, notice how the graph has changed. Any user is no longer the subject of this policy. Now it's the user that matches this specific OCID. So conditionals, like evaluating conditionals helps because it helps really like show the realistic picture of what the permissions are, as opposed to kind of overscope things or things that might not be as accurate. So in this case, right now, it's just the prod user can manage all users, and so it's a similar thing, but again, before any user is the subject. Once we add conditionals, the prod user is the subject. And then I think this is the final flag, but include all. Remember I mentioned before that by default we try to just graph privilege escalation edges. So if if you have read permissions over a bucket, that's probably not going to show up in the default graph because it's not really a privilege escalation edge. Now, if you want to include like every edge possible because you don't want to just know the lateral privilege escalation edges, you just want to know any edges whatsoever, like any relationships an entity has with any resources, you can add, again, another flag in the module. I believe it's called -- include all, and it will include all the edges, even if they don't contribute directly to privilege escalation. So like in this case, inspect secret family and secret inspect. Those would not actually be graphed because you need more permissions to read the secrets. But if you were like, you know what, I really want to see those relationships in my graph, then you can do -- include all, and you'll see a graph like this below. So the tenant group is the subject of each of these individual policies, and each policy, if there's an edge leaving a policy and is not a privilege escalation or lateral movement edge, it gets placed in a generic policy bundle edge. And you can click into the policy bundle edge to see like what the actual policies are. But if you do -- include all, you'll see a bunch of these policy bundle permissions, and so you can kind of see, okay, this node, maybe it's not like privilege escalation over the bucket, but it still has some relationship to it. And then there's so much more that I won't cover in this talk, probably in future talks, but there's a lot of other privilege escalation opportunities, like just focusing on the individual privilege escalation edges. So again, you can look at the corresponding OC Inferno wiki, and you will see a lot of these discussed. But I didn't even cover identity domains that much in this talk. And so, like I mentioned, identity domains are included in the graph. There's kind of a picture of it below where you can have an identity domain administrator role within an identity domain app, and that will give you certain permissions over users that are separate from OCI IAM permissions. Again, I'll probably cover that in future talks. I'll be speaking at Ford Cloud Sec 2026, so plan to discuss that there and maybe dive a bit more into that as well in terms of additional content. A lot of things in this tool, right? Again, check out the wiki, but you got OpenGraph, downloading, exporting data, proxying, rate limiting. Proxying is nice if you just really want to see what OCI is doing at the request layer. And then these are just the references of everything. So I've got OCI Lecture Parser, OCI Signer, OCI Inferno, which was all the OCI content. If you're interested in Salesforce, check out Forcehound. And then just a link to, again, the original OCI ANTLR blog, so credit to that for the original implementation or documentation regarding using ANTLR for OCI IAM policy statements. That's pretty much it. Like I said, all these tools are open source, free to use, pip install, git clone, whatever you would want to use there. And I will be talking about more OCI stuff here at Ford CloudSec 2026, focusing on probably some of the stuff I wasn't able to cover in this talk, like identity domains, and some other more in-depth stuff, ideally. So, yeah, feel free to check out the tools, and feel free to leave any feedback or suggestions in the issues tabs.